something like this if I did my picture right. I know yours is not in color. So I use colored pencils, and I wrote that on our warm up today, or like at the beginning of our module. You might want a couple of different colors. So if you don't have a couple of different colors, grab some. Yeah. Say that again. Oh, so who do you want to fill it out for, Kimber? You can. That would be super amazing. I love that. Okay. So grab a couple of different colors. It might help because we're going to do scatter plot and a residual plot on our graph on the inside. Okay. We're going to do a scatter plot and a residual plot. So while you guys are looking at that, I'm going to talk. So you close your face and get your colored pencils. So regression, it's an equation model. It's a model that we choose that represents the data, usually a linear, a quadratic, or an exponential. What do we use regression for? We use it to do what? Make predictions. We use it to make predictions, right? We use linear regression, or any kind of regression, really. We use regression to make predictions, okay? We use it to make predictions about values that aren't on our observed data set, values that aren't on our observed data set. So you have a picture of linear regression, exponential regression, and quadratic regression. I wanted to make sure you understand, if you're using Desmos, how to put those equations in. You guys have done linear regression, y sub 1, squiggle, ax1 plus b, but we really haven't typed in exponential or quadratic regression. It's on your handout that I gave you that has like calculator directions on one side and Desmos directions on the other, but I also wanted to make sure it was on your journal, okay? So those are the equations that you're using if you're in Desmos. And then if I go over to the right side, it talks about residuals. The residual is the difference between the observed y and the predicted y. So in my linear model, and this is where I was really wanting you guys to color because yours is all black and white, right? So I wanted you to identify with a different color what your residuals were, just so you could see them. So maybe color in, use your different colored marker, highlighter, whatever. The residual, color the residual plot so you know which ones are the residual points compared to the observed data points. So that's your linear. And then on your exponential model, your residuals are right down here. They're kind of a green color. I'm coloring them in red so you can see them. I just want you to change one of the colors so you know which ones are your residuals. Does that make sense? So like, that's all right. That's okay. So like these are your residuals. Residual right here. Yeah, just do it for the residual ones. And I made sure that when I graphed the residuals, I made them as open circles versus filled in circles so that you could identify them because I knew it would print in black and white for you guys. And then the last one that we have is a quadratic model. And the residuals are above the quadratic. So they're these light green open circles that I'm kind of putting a blue ring around. Okay. So those are your residuals. So I'm going to write a little note that helps me when I think about residuals. So let's see. A residual. My observed y value comes from where? Do we know? Where do I find my observed y value? Comes from the data table. Yeah, it comes right from the table. Your predicted y value, where does that come from? What'd you say, Violet? It comes from the what? Yeah, it comes from the regression model. Good job. It comes from the regression equation. Whatever that equation is that you get when you do the regression, right? That's where your predicted Y value comes. Sometimes you just need to write that down to get your brain straight, right? So you know how to find them. Can we go to the inside? Okay, I'll wait. Perfect. And once we're done with this, I'll scan it and post it as well in the beginning of our. You good? Everybody's good? Okay. So I need to build this table right here into Desmos. And I'm just going to split the screen and be the one that does the building. Is that okay? Good deal. You guys are amazing. So here it is. Here is my table right here. So I've already input all the data. So it says, using the table at the right, find a regression model that will represent the data best. What did you choose and why? So the first thing that we're going to do is just let's look at the table. What regression model would you choose and why? Well, let's see. My data is doing what? It looks like it's getting bigger, bigger, bigger. And it gets smaller for a second, then it gets bigger, smaller for a second, and then bigger, bigger, smaller again, and then smaller, smaller, smaller. So I chose a quadratic regression because that's the only thing that I know, right? If the direction changes, I know that I should choose what? Quadratic. So that's what I did. I chose a quadratic regression because that's all I know. So that's what I wrote here. I said, I think a quadratic model will work because the observed, and I'm just going to abbreviate that, OBS, the observed Y increases and decreases several times. So that was my choice because that's the only kind of model that we've used that shows a change, right? So I'm like, okay, well, let's just try it, see what happens. So then I went to Desmos and I'm like, okay, I'm going to build this equation and I'm asking for a quadratic model. And so I need to figure out what my parameters are. And it asks me to round all of my coefficients to the nearest hundredth. So remember that if we're doing a quadratic model, our equation is going to look like this. Y equals ax squared plus bx plus c. So we have to model that. So my values that I got are an a value of negative 0.008. My b value is 0.746. And the c value that I got was 13.468. So if I went to the nearest hundredth, how many decimals is that? I heard someone just say it quietly. Two decimals. So I'm going to underline the second decimal place in all of my numbers. So when I think about my a value, does this 8 tell me to round my a up or keep it the same? Okay, so let's start my equation. Y equals negative 0.01 x squared. Okay. Does this 6 tell me to round my 4 up or keep it the same, round it up? So plus 0.74, whoops, not 74, 75 x. plus 0.75x and then what about the C term? What's that going to be? 13.47. So plus 13.47. And that is our regression model that we're going to use. This is the regression equation. So I'm going to put a box around it, and I'm going to remind myself that this is used to make what? It's used to make predictions, right? Okay. What is my R value? That's the next question. It says, what is the correlation coefficient of your model? Well, my R is 0.9726. And so I just left that as a 0.97. So how good do you think this is going to be at predicting? How good is the predictability? Yeah, it's pretty good. Is it going to be a positive or a negative prediction? Like, it's going to be a positive, right? So I said that this is a strong positive correlation. Do you guys agree with that? Do you feel okay about that? Strong positive correlation, right? This was like yesterday's homework where we had to kind of just use words to describe what that R value meant, all right? So it says, using the graphing grid below, graph the data and include the regression curve. Be sure to label your axes. So the first thing that I want to talk about is, what does our data represent? Look at your table. What is your data representing? What's the x-axis representing? Speed. And what is the y-axis representing? Mileage. Okay. So I'm going to label that like this. Mileage. All right. So what is the speed from, what's the largest speed value that we have? 75. So do you guys remember that I can put a little squiggle in my graph? What does that let me do? We've talked about that before. It's a break in the axis. So I can jump. All my increments don't have to be the same because we always start at 0, but I'm going to jump. So this first one is going to be 15. But from there, I'm going to count by 5. So 15, 20, 25. I'm not labeling every single one because it's going to get messy. 30, 35, 40, 45, 50, 55, 60, 65, 70, and 75 goes right off my graph. One whole like grid. So I actually just took my grid and I extended it over one whole box like that. Do you guys see what I'm doing? I'm trying to make it fit all of my data. I just extended my grid over one box. So our speed is going to be in, we're going to say it's in miles per hour, mph. Is that okay? And our mileage is just in miles, right? Instead of like kilometers or anything. We're not doing anything weird. So let's graph our data points. Let's go right off the, we have to label our y-axis. So what does our y go up to? What's our total mileage? Hello, mileage. What's the largest y value that you have? 30.4. Okay. So here's how I counted this to fit everything on there. I did 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. That way I have plenty of room to fit everything in there. Plenty of room to fit all of my data. We feel okay with that? All right. So let's plot our points. plot our ordered pairs. So our first ordered pair, 15 and 22.3. So 15, and I'm going to go up to 18, 21. I'm going to go right about here, 22.3. My next one is 20 and 25.5. So 20, let's see, 18, 21, 24. So 25.5, I'm putting that right exactly in the middle of the 24 and the 27, right exactly in the middle of that grid. 25 goes all the way up to 27.5. So I just put it a smidge right over the 27 line. 30 goes all the way up to 29. Well, this is 27. I'm counting by 3. So this is 30. So I'm going to go right below that. Just kind of like that. 35, 28.8. That's really close to 29. So I put them almost at the same level. And then 40 is at 30. So that's my bobble up again. 45 is at 29.9. So that's right below the 30 again. 50 is at 30.2. So right above the 30. 55 is at 30.4. That's right above the 30 again. 60 is at 28. So I'm dropping down right in between 27 and 30. 65 is at 27.4. So I'm going to go right above my 27. 70 is at 25.5. I'm going to put that right in between my 24 and my 27. And my last one is 23.3. So I'm going to put that right below that. Real close to the 24. So that's my sketch of my scatter plot. Doesn't have to be perfect. Don't get stressed about it. Okay, that's the sketch of my scatter plot. And then it says draw in your curve, your regression curve. So my regression curve kind of goes like this. And I feel like that's pretty good. That's pretty good when I compare that to my graph over here. Pretty good. Okay. So the next thing I need to do is I need to calculate my residuals. So in Desmos, right next to this word like residuals, this E1, it typically says plot. It typically says plot, but I pushed that button. So it already plotted our residuals. So what that does is it takes all of our residual values, which is the difference. It already calculates the difference between the actual and the observed using our equation, and it puts them right here. So we're going to write these down in our table. So when I go to my table that I built right here, we need to put in our residuals. We're going to write those down. So you're going to add something that says residual across the top. And we need to put these values that are in here. And we're just going to do 2 decimal places because that's really all you can see here anyway. So when I have a input of 15, my output was 22.3. The residual for that is negative 0.51. 20, when my input is 20, the residual for that is 0.38. Do you guys see where I'm getting this from the table right here?
Yes.
Okay. When X is 25, my residual for that is 0.50. When X is 30, my residual for that is 0.52. When X is 35, my residual for that is negative 0.73. When X is 40, my residual is negative 0.19. Negative 0.19. When X is 45, my residual is negative 0.53. When X is 50, my residual is negative 0.07. When X is 55, my residual is 0.69. When X is 60, my residual is 0.08. When X is 65, my residual is 0.07. And when X is 70, my residual is negative 0.21. And the last one, when X is 75, my residual is negative 0.00. So now we have to plot the graphs of the residuals. We have to plot our residuals. I don't have a filled out copy. Well, that's just going to be ridiculous. I'm just going to do this. So I'm going to go back to this. I'm going to have to use the graph since, or like the table of values since my graph is down here. So how do we want to count this? Let's see. We know that we have to have the x-axis go from 15 to 75. What is our y-axis, basically our residual plot, going to have to go between? Is anything above the whole number 1? Is anything below the whole number 1? No, it's not. So here we go. Below -1. That's what I mean. So let's do this. I'm going to start with the 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, and I have to extend my graph to get 75. I'm going to extend my graph for 75, so I'm just going to kind of draw another little grid out here. Doesn't have to be anything fancy. And then I'm going to split this basically right in the middle. I'm going to split this right in the middle because really these X values are located where? Like my numbers are going to be, are my numbers going to be above or below my residual? Like these are, here's how I want you to understand this. This is really where your X-axis lies. This is really where the X-axis lies. So if I make this 1, 2, 3, 4, 5, if I make this positive 1, 1, 2, 3, 4, 5, this is -1, then each one of these are a point, -0.2, -0.4, -0.6, -0.8. That's what each one of these represent. And this is a positive 0.2, positive 0.4, positive 0.6, and a positive 0.8. I'm not going to raise these X numbers up here. We already know how it's counted, okay? So we're going to start plotting our residuals. We're going to plot our residuals. So I know that when X was 15, my residual was a -0.5. So that's going to be right here. I know that when X was 20, my residual was 0.38. Well, that's going to be really close to the 0.4. When X was 25, my residual was 0.5. So that's going to be in between, right in the middle of the 0.4 and the 0.6. When X is 30, my residual is 0.52. Again, right in between the 0.4 and the 0.6. When X was 35, my residual dropped down to -0.7. So put that in between the -0.6 and the -0.8. When X is 40, my residual is 0.19. So that's almost the same thing as 0.2. That's where I'm putting it, right below the 0.2, right below the 0.2. When X was 45, actually that's a negative. Did you guys see that? It's supposed to be a -0.2. I don't know if my eraser works. Sorry, this 0.2 on the 45 is supposed to be, or the 0.2 on the 40 is negative, guys and gals. And I got to grab the eraser. This is negative. So a -0.2 right there. 45 is -0.5 right down here. 50 is negative 0.07. That's not even 0.1. So it's a little less than halfway in between the 0 and the negative 0.2. 55 is 0.69. So I'm going to put that at the positive 0.7. So right in between the 0.6 and the 0.8. 60 is a 0.08. So that's less than a 0.1. So I'm going to go a little under the halfway point between 0 and 0.2 on the positive side. Same thing with the 0.7 for 65. And then this negative 0.2 for 70. And the 0 for 75. So that's what your residual plot looks like. That's what your residual plot looks like. So does that residual plot show a pattern? No, it doesn't. It doesn't show a pattern. So is this a good fit? Yes. The quadratic model is a good fit because there is no pattern on the residual graph. There's no pattern on the residual graph. It says calculate the residual for the observed data with the point 28.8. Well, when x is 35, my residual is what? That's this point right here. When x is 35, what is my residual? What is that point right there? It's about negative 0.7. You guys wrote it on your table. What did you get what was your residual value when x was 35? Okay, there you go. Negative 0.73. You don't have to do any calculations. It's already in your graph. It's already plotted for you and it's posted on your table. Okay.